Hi everybody, now we reached to the last part of chapter 1. This is the last session for us to study chapter 1. I want from you, before studying very important notes here, I want from you to check yourself if you can determine the type of waves around you. Let me ask you question and you will determine for me the type of this wave, if this transverse wave or if it's longitudinal wave. If I asked you about the sound of submarine engine under the surface of the water, this wave is called transverse wave or longitudinal wave. Try to think with me. The propagation of the sound wave of engine of the submarine under the surface of the water. This is spreading of the water of the sound under the surface of the water. It's transverse wave or longitudinal wave. Of course, the factor which help you to determine if this is transverse or longitudinal, the factor is theta, the angle between the direction of sound wave propagation and the direction of motion of water molecule. Okay, let us analyze this situation. The sound will move in a certain direction. For example, let us say this direction. The direction of the sound propagation, let us say it's this direction. But the sound move from molecule to molecule inside the water. Then the direction of water molecule will be along the direction of wave propagation like here, or will be up and down like here. Let us analyze the situation. The molecule of water and the molecule beside it, there is a large distance here between the two molecules. This will allow to the molecule to move left and right. What about moving up and down? Moving up and down, we are talking about sound wave inside the water. This means there are a huge amount of water up on this molecules. This huge amount of water will make a pressure on these molecules, so the motion ups and down will find a huge resistance from the pressure from the huge amount of water above these molecules. So these molecules can't move to up or down, but it can move to left or right due to there are intermolecular spaces relatively large between the molecules of the water. So there only one chance for these molecules to move left and to move right. Then this is the direction of sound wave, and here this is the direction of molecules of water. So angle here equals 0 due to the both directions are parallel. So sound wave produced from the engine of submarine under water surface, this will be longitudinal wave. It will be longitudinal wave. And another question. If I asked you to study the sound wave in a solid. Sound wave in a solid. Try to tap by your finger on the table and put your ear on the surface of this table. You will notice a sound passing through the molecules of this table. So I want from you to determine to me if this is transverse or longitudinal wave. Of course, you know that you need to determine the theta. Theta will help you to know the type of the wave. Okay, let us say that the direction of the sound wave in this direction, in a certain direction. This is the direction of the wave. Now remains the direction of molecules of the solid. We know from studying the properties of the solid that the intermolecular spaces between the molecules, it's very tiny. So the molecules can't move to left or right because there is no space. And there is a very strong attraction force between the molecules and each other. There is huge attraction force here between the molecules. So if this molecule will move upward, for example, due to there is energy passing through it, then this molecule will be attached to the next molecule. So next molecule will move with it to up and then return back to down, and this will take the molecule beside it with the first molecule to down. So the molecules here will move up and down. So if this is the direction of sound wave in the solid, and this is the direction of the motion of the molecules of the solid material, then the angle between the two directions equal 90 degrees. So this means that the type of sound wave in the solid material, it will make 90 degrees. This means this wave is transverse wave. This wave is transverse wave. So don't learn physics by heart, but try always to analyze the facts and data in front of you to figure out the real conclusion. Now we will move to study these very important notes. Number one, the work done by the vibrating source on the string transfer in the form of two energies. If you have a string and you pull this string downward and leave it, this string will still moving up and down, up and down, up and down till the energy ended. We need to analyze this process. You pull the string downward. You're pulling to the string downward. Means you did work on this string to pull it downward. This string has energy from you and store its energy inside the string. This storing energy inside the string, we call it potential energy. So this potential energy is stored inside the string due to the pulling of the string by your hand. So the pulling force stored inside the string in the form of potential energy. What the evidence of that? The evidence of that, if you left the string to move freely, then the kinetic energy which is stored inside the string will convert to kinetic energy, appears in front of you as vibrating motion of the string. And this vibrating motion will still happening till all the potential energy stored inside the string convert to kinetic energy. And of course, as the work done by your hand on the string increase, then the potential energy stored inside the molecules of the string will increase too, and the kinetic energy will increase too, so it will take more time to stop its vibrating. This is point number 1, that work done by your hand on the string can be represented by or divided between two types of energies, potential energy and kinetic energy. Point number 2, the wavelength lambda. This symbol here, this symbol is called lambda. We write it lambda. We write it like that, lambda, but we say it lambda. Lambda is the distance between 2 points have the same phase. These 2 points may be 2 crests or 2 troughs in the transverse wave, or between 2 compressions and 2 rarefactions in longitudinal wave. But if we want to calculate the wavelength, if I told you that we have 100 complete oscillations, we have 100 waves. These 100 waves covered a distance equal 10 meters. What is the length of one wave? Of course, you will divide 10 over 100. This will be 0.1 meter. So the rule lambda, it's a total distance which is covered by the wave divided by number of waves. This is lambda. So here we can put a definition for frequency in terms of lambda. We said that the frequency is the number of waves in 1 second, and each wave has a wavelength. So we can replace waves by wavelengths. So we can say that frequency nu, it's the number of wavelengths covered by the wave in a certain direction in 1 second. This is the frequency. And the periodic time T2, we can define T. T is the time, T capital, the periodic time. It's the time which is needed to make one complete oscillation. One wave, we can replace one wave by one wavelength. So T, periodic time, it's the time for the wave to cover one wavelength. The next point, sound propagate in gas in form of course, from our analysis we found that sound propagate in gas, the angle between the sound wave and the molecules of the air equals 0 due to they are parallel. So sound propagates in gas in the form of longitudinal wave, but sound propagates in solid in the form of course, due to that the angle between the direction of wave propagation and the direction of a solid molecule equal 90 degrees. This means that this wave, sound wave inside the solid, it's a transverse wave. What about the water wave? Water wave on the surface of the water, as we said before, water wave make angle 90 degree with the direction of motion of the molecules. This means that this angle is transverse wave, but the wave water inside the water, here the water wave make angle 0 with the direction of water molecule. Why? Due to the huge amount of water above the molecules inside the water, which prevent the molecules of the water inside to move up and down. This means the angle will be 0, so these waves are called longitudinal waves. These notes are very important. Now let us discuss together this question. As you see in front of you, this is a wave, moves ups and downs. It consists of crests and troughs, so this wave is called transverse wave. This wave starts moving from 0, and it's covered, as you see here in front of you, it's 5 centimeter to up and 5 centimeter to the down, 5 centimeter to the positive direction and 5 centimeter to the negative direction. And this is the distance, y-axis, and here x-axis represent the time in seconds, 0.24681.2 seconds. The total distance which is covered by all these waves equal 60 meter. First, we want to calculate wave amplitude. Try to think about the answer. Of course, this is the amplitude due to it's the maximum displacement away from the rest position, so we call it amplitude. So the amplitude will be 5 centimeter. This is the amplitude. What about the frequency? Frequency equal n over t, number of waves over total time, due to it's the number of waves which is covered in 1 second. So here how many waves? Of course, we count the waves between 2 points. 2 points have the same phase, same location, same direction. So this is 1 wave, 2 wave, 3 waves. So these 3 waves, as you see here, this is the number of waves is 3, and the total time here is 1.2 second. So frequency equal 3 over 1.2 second. This will be measured in hertz. By using your calculator, you can figure out the value. What about the wavelengths? First the periodic time. The periodic time, it's the time to make one complete oscillation, and here the time to make one complete oscillation, it will be here, and we can use the rule to calculate it. T capital, it's the total time over number of waves. Total time, it's 1.2 over number of waves is 3. By dividing 1.2 over 3, you can find the periodic time t, and its measuring unit will be in second, of course. The last one here, the wavelengths. The wavelengths, its symbol is lambda. Lambda, its rule equal total distance over number of waves. Total distance over number of waves. So total distance in front of you here, total distance in front of you is 60 meter, and the number of waves here is 3, so lambda will be 60 over 3, so it will be 20 meter. It's the wavelengths. This is this problem, and as you see, if you understood clearly the relation between the physical quantities and you studied the rules carefully, you will find that the relations is very clear and the problems is so easy to study. The last part here, the electromagnetic waves and the wave equation. This equation is very important. Here, notes about the electromagnetic waves. They are waves originated from vibrating electric and magnetic fields having the same phase with frequency perpendicular to each other and to the direction of wave propagation. And I want from you to know that the speed of electromagnetic wave is constant, doesn't change, but they may differ in lambda and frequency. They may differ between each other in lambda, the wavelengths, and nu, the frequency. Electromagnetic waves propagates in materialistic and non-materialistic medium. They are because they can propagate in air, the medium, and in space. There is no medium there. Transverse waves, they all transverse wave due to the electric field and magnetic field make between each other 90 degree. Here the electromagnetic wave like visible light, radio wave, X-ray, and gamma ray. Now let us discuss the last point here in your chapter 1 in physics, and as you see it's very simple. We want to discuss the relation which can be used to calculate the velocity of propagation of the wave. We will depend on this deduction on a rule you studied before, that V equal distance over time. We will call distance x and the time t. X is the total distance which is covered by the wave, and t is the total time which is required for the wave to cover this distance. But let us take a specific length for this distance, which is called lambda. This is lambda. If the lambda is the length, so the time will be the time for making one wavelength. This time for making one wavelength, it will be called periodic time. So if x is lambda, then t is t capital. So V equal lambda over t. We know here lambda over t. This is the same lambda times 1 over t. And of course you know that 1 over t it's nu. So we can replace 1 over t by nu. Then from here V equal lambda nu. This equation is called the wave equation. So from here we need to put a definition for the wave velocity. The wave velocity is the distance covered by the wave in 1 second in a certain direction. But before moving to the last two notes in chapter 1, I want from you to know that from here V equal lambda nu. This means the relation between velocity and lambda, directly or inversely. Try to think, but think properly. V is the distance covered in time, and lambda is the distance covered in periodic time. So of course there is the directly proportional between V and lambda. So as lambda increase, of course V will increase. Okay, what about the relation between V and the frequency nu? V is the distance covered in a certain time, but nu it's the number of complete waves in 1 second. There is no relation between velocity and the frequency. May the frequency increase or decrease and the velocity stay constant as it is. May the velocity increase and decrease and the frequency stay constant as it is. Frequency can be changed only by change the energy of the wave. This due to the mathematical rule you will study, but next year, that nu equal energy of the light wave equal h nu. This h is blank constant, but you will study this relation next year. But to understand the relation between energy and the nu, the frequency, the energy directly proportional to the frequency nu. So if frequency increased, of course energy will increase too. So here there is a direct relationship between velocity and lambda, and there is no relation between velocity and frequency. So if I told you you have a sound wave, and this wave traveled from air to water, of course the speed of sound will increase. This means the speed v of the sound increase. This means the lambda will increase, of course. But what about nu, the frequency? The frequency will stay as it is without any change, due to there is no relation between v and nu. But what about these two notes in front of you? You know that the wavelength is inversely proportional to the frequency at constant wave velocity. If you wanted to study the relation between two factors, you need to fix the third factor. You can't change three factors at the same instant. So if you wanted to study the relation between lambda and nu, you need to make the velocity of the same wave is constant. So you will figure out here that the wavelength is inversely proportional to the frequency at constant wave velocity. So lambda inversely proportional, so the ratio between lambda 1 and lambda 2, it will be nu 2 over nu 1, and this is the inversely relation. The last point here, the velocity is directly proportional to the wavelength, of course at a constant frequency. So at constant frequency, the velocity will be directly proportional to wavelength lambda. So as you see here, lambda 1 over lambda 2 equal v1 over v2. This is the end of this part of physics for senior 2. This is called the wave motion. But before leaving you, I want to repeat these notes to understand and to take care of it. Please, physics needs from you to understand each part carefully, need from you to practice daily the questions of physics. Don't study physics when you are out of form or when you are very tired. Please choose the perfect time to study physics. This will help you to get a high mark in it. At the end, I want to thank you for your time and wish to you to catch your dreams. Goodbye and thank you very much.